Okay, this is some help with 5.04 quiz. The first two questions on the quiz are going to have tree diagrams for you. And so here we want to take a look. We've got two different types of scenarios. So here we've got a bag that contains 4 black marbles and 2 red marbles. Philippe draws from the marble bag. Philippe then replaces the marble and Peyton draws a marble. What is the probability that Philippe and Peyton both draw red marbles? Okay, so we've got, first you need to look at your scenario and ask yourself, well, how many events are going to occur? So we've got the first event, or our first draw, where Philippe is going to draw. And so let's take a look at that. So you add, we've got 4 black marbles and 2 red marbles, so that's going to give us a total of 6 marbles. So our total, this is our formula, remember, the probability of an event is the number of events possible, that's our favorable outcomes, divided by the total sample space. So our total sample space are the total marbles, 6 marbles. All right, we want to know the probability of red. So there are 2 reds, and we're going to go ahead and put the blacks here too in our tree diagram. So our tree, we can draw red, we can draw black. The percentage of each, we can draw 2 reds out of the 6, or we can draw 4 blacks out of the 6. Okay, so if we draw a red one, he's going to replace that marble. So our second draw is Peyton drawing. And so our second draw, the odds are just the same, right? We still have 6 marbles, 2 red, 4 black. If he were to draw a black one, our odds are still the same. We still have 2 red ones and 4 black ones. So these are the same as these. If he is drawing a red the first time and drawing another red, we look at those percentages. So 2, 6 times 2, 6 is 4 over 36. That can be reduced, that fraction can be reduced to 1/9, or if you take 1 divided by 9 times 100, you get 11%. Now the difference here, notice, is with and without replacement. So our second draw is affected by what happened in the first draw. So this says what happens to the probability if Philippe does not replace his marble in the bag. So we've got the same scenario almost. Philippe's going to draw a red one. So notice the tree diagram, these are the same. We still have 2 out of 6 red ones, 4 out of 6 black ones. But here, if he draws a red one, now we only have 1 out of 5 red left, right? Because if he doesn't put it back in the bag, there are 1 less marble, so now he only has 5 marbles, and there's 1 less red, so he has 1/5 red, and still has the same 4 black ones, but now there's only 4 out of 5 that are black. So this scenario, the tree diagram, if you follow this diagram, this says, oh, well, what if he drew a black one? Then we still have 1 less marble, but here we still have 2 red ones, so 2 out of 5, and here we only have 3 black ones. So that's how you do your tree diagram. And then you look at, well, what happened? All right, he drew a red one, and we want another red one. So we have this percentage, 2 6 times 1/5 gives us 2 over 30. That'll reduce to 1/15, or 7%. So on your tree diagram, be careful to see if the second event is affected at all by the first event, and then you would have to change your denominator and your numerator possibly. All right, let's take a look at this example. This is very similar to one on your quiz. I've just changed the numbers. So we've got a jar containing 15 apple lollipops, 5 strawberry lollipops, and 9 grape lollipops. Irvin randomly selects a lollipop. He's going to give it to his brother, and then he's going to randomly select another lollipop for himself. Okay, so he's not going to replace that lollipop. He's giving it to his brother. So what is the probability that Irvin is going to select first a grape lollipop for his brother and then an apple lollipop for himself? Write it as a percent, and then be careful. It says round to the nearest 1/10 of a percent. So all you're going to do, if you look at the blank, it gives you a percent sign. So all you're going to do is make sure you put the answer as a 1/10 of a percent. So our formula, probability of this event happening, is going to be the favorable outcomes divided by the total number. And now, how many events? We have 2 events, right? So he's going to select 2 lollipops. So that's 2 different events. So first, let's get our denominator. I kind of like to look at the denominator first. What is our total sample space? And we're simply going to add the number of lollipops, right? That's going to be our total possibilities, because that's how many lollipops are in the bag. So 15 plus 5 plus 9, we have a total of 29 lollipops. So let's look at each event. We're going to have event 1, we're going to multiply it by event 2 to get our final probability of both happening. So denominator for our first event, we have 29 lollipops. And then it says selecting a grape first. So if you look, we have 9 grape lollipops. So 9 out of 29. If we just had one event, that would be how many the chances of getting a grape lollipop. All right, but now we're going to assume he got a grape lollipop, gave it to his brother. So now instead of 29 lollipops in the bag, there's only 28. Because he gave one to his brothers. 29 minus 1 gives you 28. But the second one, we want an apple lollipop. And so he drew a grape one first, so we still have 15 apple lollipops, right? So 15 over 28 is our chances of the second event happening. So then we're going to multiply our numerator. 9 times 15 gives you 135. 29 times 28 is 812. And then depending if they left the answers choices as fractions, you'd want to reduce that fraction, but they want it as a percent. So what you're going to do here, let me drop this down just a little bit so we can see that number. We're going to take 135 divided by 812, and then you can multiply by 100 in your calculator. Or if you don't multiply by 100, you'll get a decimal, 0.166. And then remember, you're going to move it 2 places to the right. And then it says, so there's your new decimal, 16. And then the 1/10 is 1 decimal, so 16.6%. Okay, my last one here is similar to the one that you're going to have. So we've got a game show, and we've got 10 keys that are in the bag. 3 of the keys start the car. A contestant is randomly going to choose a key. It does not start. She's going to return it to the bag. The host is going to mix up the keys. She selects another one, and she chose one that does not start again. So what is the probability of this happening? No start the first time, no start the second time. So remember, we've got 2 events, right? She's drawing 2 different times. So event 1. Now, there are 3 keys that start the car. That means if we subtract 10 from 3, there are 7 keys that do not start the car. So 7 divided by 10 is going to be the chances of her getting a no start on the first draw. Now, she puts the key back in the bag. So we still have the same probability that she's going to get a no start the second time. So we're simply going to multiply these. 7 times 7 is 49. 10 times 10 is 100. So if we divide this, multiply by 100, we get 49%. Now if we change it up a little bit, what is the probability of no start? So the same first draw, and then start outcome. Now she's going to win the car. So let's take a look how that would change. Our first event, 7 out of 10. Our second event, now there are 3 that start the car. So 3 out of 10 is going to be our probability of the second draw. multiply these together, and so she has a 21% chance of actually winning the car on the second draw. Hope this helps.